We are in section 1.3, lines and linear functions. A linear function is a function whose graph is a straight line. We have different types of slopes that describe these shapes of these straight lines. The first one that we have is positive, which is rising from left to right, negative, which is falling from left to right, zero, which is horizontal, and undefined, which is where we have a vertical line. The slope of a line through the points x1, y1, and x2, y2 can be found by having m, which is the variable we use for slope, of y2 minus y1 over x2 minus x1. Another way to think about this is rise over run, or the change in y over the change in x. So definitely things to know and should know how to calculate. So the example right below says find the slope of the line passing through the points -2, 3, and 1, -4. So I'm going to go ahead and call the first order pair x1, y1, and the second order pair x2, y2. And again, our slope formula is written right up above. And so we have y2, which is -4, minus y1, which is 3, over x2, which is 1, minus x1, which is -2. And so simplifying this, we have -4 minus 3, which is -7, over 1 minus -2, which is 3. And we leave slope as an improper fraction. If you can simplify it, but 7 and 3 cannot be reduced. So we have another example right next to this, the same thing, finding the slope and labeling my first ordered pair x1, y1, and my second ordered pair x2, y2. So the slope is going to be y2, which we have is 13, minus y1, which is 6, over x2, which is -20, minus x1, which is -3. So from here, 13 minus 6 is equal to 7. And then -20 minus -3, or plus 3, would be -17. And again, we are unable to simplify this, so that would stay our final answer. A method used to graph linear equations uses properties of the line. We will find the slope and the y-intercept, which again, remember, y-intercepts are where x is equal to 0, and so we're going to call it 0, b, of the graph and arrive at the slope-intercept formula, which is y equals mx plus b. So again, another formula to make sure you know. So the example right below says to rewrite the equation in slope-intercept form and state the slope and the y-intercept and then graph. And so we have 3x plus 2y equals 4. So to get this in slope-intercept form, we do need to solve for y, which means we need to isolate the variable y. So subtracting the 2x on both sides, we get 2y equals -3x plus 4, and then dividing all of our terms by 2. This is going to simplify to y equals -3 over 2x plus 2. And so our slope is going to be -3 over 2, and our y-intercept, which we call b, is going to be +2. And so from here, we need to state our slope and our y-intercept, which is 2. That point is going to be 0, 2. And so to graph this, we're going to start with b, which is our y-intercept, which is at 0, 2, and I'm going to put a point. From here, we can use our slope to find the next ordered pair. So our next order pair, since our slope is -3 over 2, I'm going to go down 3, right 2. And we're going to start from that y-intercept that we just put the point on, our graph. So down 3, right 2, put another point. And continue this pattern, down 3, right 2, put a point, down 3, right 2, put a point. We cannot fit any more on here. From here, I'm going to make a straight line connecting my points that we have. And this is our graph, and then we also stated our slope and our y-intercept here. On the next page, we have a few special cases that we see quite often. The first one is saying to graph y equals -2, and the second one says to graph x equals 3. And so for both of these, you'll notice that the equation isn't very dense. It doesn't have a slope and a y-intercept necessarily. And so for the first graph that we have, I'm going to go ahead and draw my coordinate plane and go 3 each way. And for this problem, it says y is equal to -2. Y is always equal to -2, and y is equal to -2 at this point. Also at this point here, 1 comma -2, 2 comma -2, 3 comma -2, -1 comma -2, -2, -2, and so forth. So if you notice, this is going to make a horizontal line here. And this is our graph y equals -2. But use the same logic but for the next one, but this time instead of it being y equals, it's an x equals. So again, drawing my coordinate plane, I'm going to go 3 each direction. And for this problem, it does say x is equal to 3. And I'm going to put a point at x equals 3. And also note that at point 3, comma 1, x is equal to 3, 3, comma 2, x is equal to 3, 3, 3, x is equal to 3. Likewise, going the opposite direction at 3, -1, we still have x is equal to 3. And putting all these points on and then drawing my vertical line, we have x is equal to 3. Couple things to note. The first one, you have the first example that we did, y equals -2. Slope was equal to 0. The second one that we just did, our slope is undefined. So slope would be undefined. From the slope equation between points x1, y1, and x, y, we can derive the point slope equation of a line. And so the point slope form of an equation of a line with slope m and passing through the point x1, y1 is y minus y1 equals m times x minus x1. So the example right below says find the slope-intercept form of the line with the given information. And so for the first one, we have the slope, and we also have a point x1, comma y1. And so our formula is going to be y minus y1, which is -4, equals m, which is -2/3, times x minus x1, which is 6. From here, we just are going to clean this up a little bit. We have y plus 4 equals -2/3 times x minus 6. And so this is called our point slope form. So this is point slope form. And it does want this also in slope-intercept form. So to do that, I'm going to distribute my 2/3, the -2/3, and have y plus 4 equals -2/3 x. And -2/3 times -6 is going to be +4. And then subtracting 4 on both sides. To isolate my y, we get an equation y equals -2/3 x, and this form is going to be our slope-intercept form. So the example right next to this one, instead of giving us the slope and an ordered pair, it gives us both ordered pairs. So I have x1, y1, and x2, y2. And so the first thing I need to do is calculate my slope, which again we saw was y2 minus y1 over x2 minus x1. Simplifying this, we get 1/3. Rewriting this, I'm going to first do point slope form. We're going to have y minus, and you can pick whichever point that you would like to use. I'm going to go ahead and use that first ordered pair. So y minus y1 equals 1/3 times x minus 0. And so this would be my point slope form right here. And then solving this for y and distributing my 1/3, we get y equals 1/3 x plus 1. And this would be my slope-intercept form that we would have. The example right below says a company rents cars for $40 a day and 15 cents a mile. Its competitors' cars are $50 a day and 10 cents a mile. Part A says for each company, give a linear formula for the cost of renting a car for a day as a function of the distance traveled. So I'm going to go ahead and call company 1 Y1. And so it's going to cost $40 a day plus 15 cents a mile. So we'll say $40 plus 0.15 times x, and we'll say let x be, we'll write it up above, let x equal miles traveled. And again, it's 0.15 because we are dealing with cents for that, and compared to the 40, which is in dollars. The second company that we have is $50 a day plus the 10 cents for miles traveled. So we'll have 0.10 times x. So part B says at what miles driven is the cost of the companies the same. And so in order to do this, we need to set y1 equal to y2. And so for that, we have 40 plus 0.15x equals 50 plus 0.10x. And then I would subtract 40 on both sides. And then I'll also subtract my 10.10x. And so from this, we're going to end up with 0.05x equals 10. And then dividing by 0.05 on both sides, we get x is equal to, we get 200. And x again was the miles traveled, so this will be miles traveled. So it will be the same cost if you travel 200 miles. And it says, how should you decide which company is cheaper for part C? So it should be based upon that 200 miles traveled. So if you travel less than 200 miles, we would use company 1 and company 2 if you travel more than 200 miles. There is an interesting connection between the slope of lines that are parallel and slopes of lines that are perpendicular, which means that they meet at a right angle. So the first thing is, for parallel lines, you'll notice that the slopes of line 1 and line 2 are the same. So we'll say M1 is equal to M2. And for perpendicular lines, you can see line 1 and line 2, they intersect at a 90-degree angle, and their slopes are going to be opposite reciprocals. So the slope of 1 is going to be negative 1 over the slope of the other. And so the example right below says find the slope of a line parallel and perpendicular to the given line. So for the first equation, I already have this in slope-intercept form. So we can see that our slope is equal to negative 10/3. And so the slope of a parallel line would be the same thing. It's still going to be negative 10/3. And this would be for parallel. And then for perpendicular, we're going to go ahead and take the reciprocal, which means flip the top and the bottom number. So we're going to end up with 3/10 and change the sign. So we're going to end up with positive 3/10, and this is going to be for perpendicular. For part B, we have to do a little bit more work since it's not in slope-intercept form and I cannot easily see that slope. So we need to first isolate our y. So to do that, we need to subtract 8x. So subtracting 8x, we get negative 3y equals negative 8x minus 9. And then divide every single term by negative 3 in order to isolate y. So we have y equals 8/3 x plus 3. And so our slope here is going to be 8/3. It's always the value that's in front of our x. So slope is 8/3. So parallel slope, we would have the same. 8/3 would be for parallel. And for perpendicular, we're going to take the reciprocal and change the sign. So it's going to become negative 3/8. and that's going to be for our perpendicular slope.